Thank you, everyone. Thank you. So let's get right into this. I got a couple questions here already. I did see a couple come through about the PowerPoint and how we're going to get that. Like Andrew mentioned, we will be emailing that out. So keep an eye out for that in the next 24 hours or so. But first question here, I got a question on accelerating the cure using heat. Chris or Tara
Sure.
or Michael.
Yes.
You mentioned that a couple of times. Could you explain that a little bit further?
Sure. So the products that we're talking about are two-part addition cured systems or platinum cured systems. So when you apply heat to these chemistries, that reaction rate will speed up. So again, depending on what temperatures your parts can afford, the hotter you go, the faster reaction rates that can happen. So again, the good rule of thumb is every 10 degrees you rise, that reaction rate speeds up or cuts that time in half, or that cure rate in half. Does that answer the question?
I believe it does. I believe it
Okay.
does. Terry, do you have anything to add, or anybody else?
Nope, I think that covers it. Yeah.
Okay, great. I got a couple questions here on the primer, actually. How is it applied? And if you could review the benefits of the primer, number 5 specifically, that'd be great.
Sure. So primers can be dipped, sprayed, brushed. Primers are a very low viscosity material, very water-like. So again, you want to put, primer is one of those chemistries you want to put the least amount on. And in particular, primer 5 is a non-hazing primer. So it's really designed around areas where you may have to attach it to a clear lens or over an LED or glasses involved. So it's a material that doesn't leave a haze, and it's used where you need optical clarity. Whereas primer 3 is a little bit more aggressive. It's an excellent primer for plastics and other metals. So that's really the differences between those two. We have multiple primers for you. So again, we can gladly help you select the correct one. And it's designed to increase adhesion of silicones.
Perfect. Thank you. I have another question here on the color of the LEDs. Will the coloring shift on the silicone? I'm sorry. Will the silicone's color shift in LEDs?
So when you apply a liquid to an LED, yes, you're going to have color shift. Now, silicones generally, that shift will be less than other organic chemistries out there, but there is going to be a shift for it. So again, in each LED manufacturer, the shift can be different. So it's going to require some evaluation on your part. So it's again, but you will see a shift no matter what you put on it. However, silicones will shift it less than other chemistry. And the other benefit is if it does age it, as a chemistry ages, it doesn't discolor, so it maintains that same clarity as compared to an epoxy urethane.
So whatever clarity you get and whatever light transmission, whatever color shift you get when you first produce it, that's the kind of color shift you can expect, a year, 2 years, whatever down the line, to kind of put that a different way, right? Would you agree with that, Chris?
Yes.
Yeah, and I went ahead and shared this slide that had a little bit earlier. I know sometimes people are kind of in and out, but this is kind of maybe worth showing again real briefly because this kind of speaks to the question. So we look at the different wavelengths of light. So you can see a pretty even amount of light transmission across the wavelength. There are a couple of dips in lower areas, but then if you were to look at a similar chart for other kinds of chemistries, I'm sure you'd see a much, and maybe if we could provide that after the fact. I don't have that handy this moment, but you can get an idea, at least just visually looking at those, the polymers on the left, which are the silicone compared to other polymers. And that's just looking at the aging. So I don't know if we mentioned this on this slide, but you could see that what we do is we put those in a chamber, which accelerates the aging. So you see that that's the second column is 6,000 hours, and then the other one is 6,000 hours plus heat. So you can see how the silicone remains pretty constant throughout that process, and other types of chemistries, might not have that same performance. So to kind of sum up Chris's answer, yes, but yes, it will shift, but to what extent is really the question that you're talking about when you're looking at laying a material over an LED.
Right. It is best to test, qualify, and design your parts, understanding that impact. And like you said, it's not going to change afterwards, but to understand that up front of what color you are trying to and how it is going to happen. So just test and qualify that. Design your part understanding that.
Great. And I can add that we've sent CHT plenty of samples in the past, and they can test that for you too, just to give you a heads up. I have another question here as far as UV. Will the silicones degrade in UV?
So silicones themselves, and they will not degrade against when exposed to UV. So again, whether it be outside or from the light itself, they don't degrade from UV exposure. And you can see that transmission rate. Now, again, use that chart as best possible. If you're looking for something that's lower than the 450 range, then we should have some more discussions, because you can see the transmission rate drops off at a lower value, lower nanometer or wavelength. So that should, yeah, but general exposure to the sun, no, they will not degrade.
Perfect. Thank you. Thank you. I got a question here from Robert. He asked that they would like to cover the LED strip circuit boards so you don't see the circuit runs. He asked if you could use a black silicone and barely cover the LEDs so the LED light comes through, but you don't see the circuit board.
That's a great question, Robert. When you do use this material, particularly the 336, it's used today in that kind of application. Yes, you want to try to minimize that coating over the LED if you happen to get there. I would say it's not it will allow you that light to shine through with a very thin film, but yet still cover up the paths that you're asking about. So again, you can do that, and that's a good product to start with, is the Tough Gel 336.
Right, and you have other customers that have done this application, and I think there's products on the market that use that particular chemistry that are available today, right?
Yes, yeah, and black's nice because it's a contrast enhancement, but yes, that's exactly where what we have. So really offer two chemistries in this market space. I like Tough Gel 336, but there's also a product called 556 that Tara had mentioned. The benefit of the Tough Gel, it will self bond. You do not necessarily need a primer. The 556 would be recommended that you use a primer. But again,
and Chris, for that application, I mean, like some of the LED boards like that you see, like the signage kind of boards, like that almost like look like kind of outdoor kind of TV kind of things with the small LEDs, those kinds of products, like some of those are used in that kind of application as well, besides just LED strips with the color enhancements.
So yeah, digital displays, digital billboards generally use these contrast enhancement materials, and 336 is extensively used in those.
Okay, so there is, just to kind of communicate the kind of track record there. So this is definitely something that we can cover. Now, this is a question related to that. Would you then need to put a clear silicone on top of that to then cover the LED, or as long as the board is covered, even if the LED is poking out the top, is it then sufficiently waterproof, or would you need to do a coat on top of that?
Well, again, we'd always tell you, again, you want to expose it to the environment where it's going to be used in. However, with the 336, it will have adhesion to the LED. Again, based on your environments, we'd recommend you test it. But yes, I would consider that sufficiently covered and protected.
So you probably wouldn't need an extra. You may or may not need an extra coat of clear.
No, I wouldn't suggest it.
Okay.
Not initially.
Perfect. Thanks, guys. I got a question here from Riza. He's saying, for high power application, how is the stickiness of the silicone on the surface? They added, for high temp generally, sealants getting far from the surface affect the color of the LEDs, and they're looking for high color temps.
So let me understand the tackiness of the material. Let me understand.
For high
I believe that's, yeah, the tackiness of the silicone on the surface.
Okay, so again, silicones are going to be, I guess maybe it's related to a dust attraction. So again, a high durometer kind of material would be more desirable. There is going to be color shift reason. There will be color shift, but again, if you can adjust the LEDs that you use for the temps that you're looking for, you could do that, but from a tackiness, I would look at probably suggesting a higher durometer if possible.
Right. Now, don't people sometimes use, like, say if they used even if they used a lower durometer, would there sometimes still be a plastic lens or something on top of that? You know, is that could maybe be an option as well to kind of prevent
Sure.
the dust and whatever collection, whatever debris might be forming on the surface?
That is correct. Yeah. So that is correct. And again, that's where some of the lens molding materials may be used in those applications for that very high duro material. Again, for if dust is really the concern there, or the attraction of dust causing the shift,
Right.
I would suggest something like that.
Now, this is something I heard about years ago. It just occurred to me now, but was there some kind of coating you guys were developing to kind of make the silicone less sticky, or is that something that wasn't actually commercialized?
Yes, but I wouldn't recommend it in this application. It'll haze the chemistry. It's designed to make silicones decrease the friction of the silicone, but it's not generally used in this application.
Okay, yeah, I remember you mentioned that something a couple years back. That sounded like a neat idea. I was curious if that was something that was ever came to market. So, sorry, go ahead.
Great, thanks, guys. I got a question from Michael here. He asked, would you say that 214 under the chip height that we showed would be good for waterproofing in a lensed fixture?
Yes, I would recommend 214. Again, I would suggest probably a primer be applied to give you a best adhesion, but it's an excellent product for that kind of application.
It looks like you had a follow-up question about that primer number 5.
So yes, the thickness can shift the temperature. So the thicker it is, the larger the shift potentially. But I would tell you, Michael, you would just want to evaluate it. It varies from chip to chip, or say chip maker or LED maker. So again, I would look at again, thinnest coating over it would be desirable.
Yeah, and Michael, so you asked about the primer number 5 as well. So I think Chris mentioned a little earlier, but just to reiterate that this can be sprayed, dipped, brushed, and it's a solvent. All the primers that CHT offers are all solvent-based chemistries that kind of flash off. So basically, the primer would be applied to the part, left to flash off. What would you guys say, like 5 or 10 minutes? Is that generally what it would take at room temperature, depending on the humidity?
Yeah, that'd be a good example, but
yeah.
Then you could apply your silicone, and then after you have applied your primer, I would think you have some kind of window to then apply your silicone before you'd maybe need to reapply the primer. So is that good for a couple hours, or is that overnight, or what would you say after they apply the primer? How long do they have to apply their silicone?
Generally, I would say no more than a day. A shift. That I would desire. 24 hours is max on some of these, but it'll state right on the data sheet how long on part life is.
Yeah. And then, a lot of customers that I talk to about these applications, a lot of people are understandably concerned about the use of a primer. It's certainly an extra step. And, if you can avoid it, I think most customers want to. So I usually encourage people, I don't know if the CHT folks might agree or disagree, but I think you could certainly try it both ways when you're doing your evaluation. So you perhaps might want to try it without the primer first. If you're getting satisfactory adhesion, you could maybe save yourself a step depending on the material. The silicones, you're kind of always with silicone chemistries and really adhesives and 2-component polymers generally are always kind of trying to balance cohesion and adhesion. So the silicones kind of tend to have higher adhesion. And so, maybe compared to a urethane and epoxies, the urethane and the epoxies might have higher adhesion, but it's just part of the pros and cons of the different process. When you use the primer and you're getting the results you want, you're at the end of the day, you'll probably end up with a better system that's going to meet more of your requirements. And the addition of the primer being a one component that only adds maybe 5 or 10 minutes to the process in terms of waiting for it to flash off, you're not giving up a lot in terms of time and getting a lot in terms of all the other performance characteristics. So I think when you look at everything on balance, I think using a silicone with a primer, depending on your needs, we won't say that silicone is the best fit for every application. We're going to be a good fit for a lot of ones. Anywhere where there's impact, anywhere where there's environmental concerns where you want the maximum longevity, those are maybe the applications where silicone's maybe the best fit for you. And then in that scenario, I think you're probably in a good situation using a primer as long as the results you're getting are satisfactory. Would you guys agree with that, or you say you think you guys always need a primer more or less?
No, again, it's always based on the scenario. So again, it's always come down to testing, just to prove it out on your parts.
Yep.
Whether you get strong enough mechanical adhesion or do you need additional chemical adhesion. So again, it all based on the chemistries you select. There's products that you do not need a primer, and there's products that you would be suggested. But again, it should be just evaluated. That's
right. And one of the big difference variables there would be the material of the housing or the material of the channel itself. So would you say the silicone is more likely to have higher primerless adhesion to certain materials versus others? So say to aluminum versus plastic. Do you think you're more likely to need a primer on one material versus another?
Yeah, it all depends. Again, it all depends on the chemistry that's there. What's on the aluminum, or what has been, what kind of plastic you're using. So it's really just should be evaluated, and we can give you suggestions, on what to do there to increase the adhesion on certain surfaces.
Yeah, and kind of speaking of adhesion, just the kind of the general best practices of adhesion, of optimizing adhesion, just apply the same best practices that you use for adhesives and everything like that, which is having a clean, dry surface. A lot of metals will have finishing greases and oils and stuff on the surface. So making sure that you just have a clean, dry surface is just going to give you the best bonding that you can. That's just kind of a general rule of thumb for everything. I don't know if you guys ever recommend like a light scuff on the parts to kind of give you better adhesion, but certainly the more micro cracks and stuff that there is on the surface will allow the silicone to fill in and give you that mechanical connection. And then the other thing about the primers is, they have the additives that give you the better adhesion, and then they're also solvent based, so they kind of clean as well. So they almost, would you recommend doing an IPA wipe on the part first and then doing the primers, or the primers can kind of clean and prime in one step almost?
Well, again, I would suggest that you try to get as clean as possible prior to applying a primer. It's always recommended.
Great guys. I do get questions from time to time as well. Just to ask you guys, people that are using epoxies or urethanes, what's the transition like to a silicone? Is it a simple transition?
Well, again, silicones aren't compatible with polyurethane or epoxies from a dispensing standpoint. So it's going to require you to, if you've got a set of piece of equipment you want to use, that piece of equipment from a transition standpoint, you want to basically flush and replace all the hoses, any wetted parts that need to be cleaned thoroughly. But from an application standpoint, how you use a traditional epoxy and mixing to a two-part silicone it can be similar. But again, switching to a higher performing type of product. So again, they are very similar in nature that way. Again, one of the benefits when we talk about transitioning over, I always think about that second or third step of filling, because you haven't met the level due to the shrinkage of those organic chemistries. The silicone, again, you fill to a certain height, it stays at that height. And so that to me is a very big benefit in the process.
Yep. Here, if I could throw a question, and here's something that I get asked a lot as well, is we get asked a lot about like underwater, especially when we're in coastal areas. People want to make dock lighting and stuff like that. Do you guys have products or other silicones that are available that can handle underwater LED applications? And what kind of ratings? I know they have like the IP ratings that are typically measuring for how the level of seal that you get on an electronic part. What kind of IP ratings can you expect with certain silicones? Can any of you guys kind of speak to that?
Sure. Well, again, we have many applications today where people are looking for underwater lighting for boats. And again, they are looking to pot over the LED, and they have a sealed system there. They already have a lens and they have a housing. And again, that is a common application today. So again, there is a variety of IPC ratings, but again, it should pass them. And again, all these systems that we worked on have an enclosed case and lens.
Okay. So if you have a clear LED, an LED underwater dock lighting application, for instance. You know, maybe the one product that we've mentioned a couple of times is the 214. I believe those have been used in underwater applications in the past, and I think some of those parts have they achieved, what is it, the IP? I'm trying to remember the number of the certification for the underwater. Maybe we'll throw that in the email afterwards. But was it IP64 or IP16, something like that?
Yeah, I'm not sure. I'm not sure. I'd have to take a
Top
look
of my
again.
head, yeah. Okay.
Great. And you guys do carry a lot of these formulas in cartridges for, you know, small tests and things like that, correct?
Sure. So we do have a sampling program. You can, you know, a lot of these systems are designed for dispensing through cartridges. It's a great way if you use a cartridge system, it will mimic a lot of times your next move to a production snare to a meter mix system. Again, just how you apply it with a static mix nozzle, a needle tip. So it can help mimic the next step in your process of automation if you decide to go that route. But yes, a lot of these can be offered in a cartridge system.
Yeah, and yeah, that's a great transition, you know, or especially for getting started. You know, you might not have the volume in a new product that you're producing to get a meter mix system right away. So a cartridge is a kind of great in between kind of system versus you know, eliminates a lot of the kind of the pitfalls that exist in hand mixing, while certainly saving a lot of capital that would be invested in a meter mix system. Those, you know, if you haven't invested in any of the systems for any other projects, you can know that they can be quite expensive. And then, you know, other materials that are out there on the market, you might have to buy them and either get them down packed yourself by an outside packaging company or something like that, or even fill them yourselves. I've run into other customers that are kind of buying empty cartridges and filling themselves. So, you know, at Chemical Concepts, we are stocking and can special order a lot of the CHT chemistries already in cartridges. CHT has the capability to pack a lot of these materials and sell them commercially in cartridges. So that could be a great, you know, kind of added value thing for you guys if you're not quite ready or not quite at the volume to commit to a meter mix system.
Perfect. Thank you, Andrew. Well, we're hitting 12 o'clock here. It's been about an hour. I think we should just keep this open for another minute or two, wait for any additional questions that anybody and any of the attendees may have. I mean, is there anything else you wanted to discuss here, Andrew?
It looks like all the questions in the Q&A are answered. I do see some stuff in the chat. Oh yeah, it was IP68. Thank you, Stephen. Was the IP number for the sealant. Now I'm just looking at the chat here. Let's see. Do we have any other questions in the chat that we need to address that haven't been addressed anyway? Let's see. So yeah, we'll just give you another opportunity. If you have any questions that you really need answered before we break, here's your or forever hold your peace. No, but actually, you know, if you have any questions that we didn't cover here, you know, like I said, we have the contact information up, so you feel free to reach out to us if you want to go in more depth about your specifics. We'd be happy to spend some time and help you there. But yeah, I think it looks like, I'm looking through the chat here, it looks like most of the questions that are there were kind of covered anyway through our kind of conversation. So I think we can wrap up.
Great. Well, thank you everyone for attending. We really do appreciate it. Andrew, Chris, Tara, and Michael, it's great stuff, great information here. Like Andrew said, if you do have any questions, we'll be sending out the PowerPoint and all sorts of PDFs of the slides and segments of this webinar that you'll be able to see on YouTube. You guys should get that within 24 hours. But thank you again for attending, and stay safe, everybody.
Thanks, everybody.
Thanks, everybody.
Thank you.